or wherever it is that you're doing your work, but that should have been there. So you guys should have that already because we're going to be talking about today, and you also need your scientific calculators. All right. So now we're going to quickly review what it is that we did last class, which was yesterday, talking about being able to okay. So if you guys see what I have here, yesterday we were talking about radius and diameter. And when you have the formula for circumference, one formula that talks about radius and one formula that talks about diameter, you are able to change that formula or change the subject of the formula so that you are able to use that formula to find something else. All right? So now how do we go about doing this? One moment. How do we go about doing this? If I have that circumference is equal to 2 pi r and I need to make the radius the subject of that formula, it means that I need to leave r by itself. In this case, I need to remove the 2 pi, and when we do algebra, when we come back after your vacation and we do algebra, this is something that you will need to be able to know how to do. So if I want to make the radius the subject of my formula, my my formula changes so that r is the subject because I need to leave radius by itself. And I'm not going to be going into the details of how to do this because you guys, like I mentioned, it's something that I will be briefly covering with you guys doing a quick revision, but something that you will need to know how to do. So everything that we did last school year in second form, and even those of you that are repeating and are in third form, you should be able to know at least some basics of algebra, how to expand, how to simplify, how to use distributive property when it comes to using algebra. And this is one of the simpler aspects as well, changing the subject of a formula. So for me to be able to use this circumference formula that has 2 pi r, and I change that formula to make radius the subject, I can now use this formula that I have here to find radius when the circumference is given to me. And I do the same thing with the other formula. I can change the subject of that formula. When it comes to the formulas for area, I can do the same thing. If I want to make r the subject of my formula here, I can just basically go ahead and have area divided by pi is equal to r squared. And how do I remove a square? What is the opposite of square? Then I have to square root. And I find that radius is equal to the square root of area over pi. And this is the formula that I'm going to be using. And I need to know how to be able to change the formula, the subject of an equation. And the same thing with this one where you have area is equal to pi over 4 times diameter square, where I want to leave the diameter by itself on one side so that the diameter is the subject of the formula. I can go ahead and change this so that diameter is equal to some formula that I want. And if you guys have taken a look at the PowerPoint that I showed yesterday in class, the PowerPoint does give you guys all of the formulas that we need to be able to do this. So let me share this tab instead right here. Let me go back to where the formulas are. Where are the formulas? Right here. So now if we take a look at this slide, we have the three formulas for diameter. Diameter is equal to 2 pi r, diameter is equal to circumference divided by pi, and diameter is equal to 2 times the square root of the area divided by pi. And if we take a look at the formula for radius, the three formulas of finding radius, I have radius is equal to diameter divided by 2, radius is equal to circumference divided by 2 times pi, and radius is equal to the square root of area divided by pi. And I'm going to be using these formulas to solve questions. So, for example, let me go back over here on this one. I gave you guys and I showed you guys this question yesterday that says, what is the radius? What is the 100 meters? What does this 100 meters represent?
Circumference.
Circumference, very good. So I need to go and see which formula has radius but also has circumference. And it is this formula. So I'm just going to substitute what I know into this formula. I am looking for the radius. I know that the circumference is 100. That is at 2. And I know that pi is 3.142. What is going to be your answer for this question? You have your calculators. Use your calculators. Anybody?
157.1, Miss.
Repeat again.
157.1.
157.1. That is what you get? Are you sure?
Yes, Miss.
It is 100 divided by open brackets 2 times 3.142 close brackets. You should get 15.9 meters to one decimal place. You need to be able to, and careful guys when you're using your calculator. Some calculators are very advanced where you can put in it has a fraction button. If you have one of the Casio calculators like the green ones, there is a little fraction button where you can put a fraction and you put 100 at the top and then 2 times 3.142 at the bottom. If you have one of the normal blue calculators, you need to be able to put your operation correctly into your calculator. So how do I put all of this into my calculator? I'm going to put 100 divided by 2 times 3.142 close brackets and then the equal sign. So put this in your calculator and see what that gives you.
Miss,
Yes.
it gave me 628.4.
6
28.4.
628.
0.4.
It should not give you that.
Miss, I get the answer right here, Miss.
Okay, Jerome, it should be 100 divided by, and then open brackets. I think you put multiplication there because I don't see how you would be getting 600. It has to be 100, then the division sign, open brackets, 2 times 3.142, close
Yeah, Miss. Yellow,
brackets.
yellow, yellow, yellow. Mereka malas ke pulsa times.
Aha. Okay, good. Okay, so everybody understands how to do this one? Everybody got it? How we use the formula?
Yes.
So now,
Yes.
this one is one question that is in your package or in the activity number 2. I think it's the first question if I'm not mistaken. But it says, and let me read it, your friends join you for a hike in Poconos. There you find a massive redwood tree. You are told you'll get extra credit in geometry if you can figure out the diameter without cutting it down. One of your friends has an idea. If you can measure the circumference of the tree, you can figure out what the radius is, right? Which will then help you find the diameter. If the tree circumference is 43.2 feet, what is the diameter? And in this case, we have a formula to find diameter that includes circumference. And if you go to the PowerPoint and you look up that formula, diameter is equal to circumference divided by pi. Very straightforward, right? So if I'm looking for the diameter, I know that the circumference is 43.2, and I'm going to divide it by the value of pi, which is 3.142. What do you get?
Meaning by
0.75.
3.2 divided by the pi, which the answer that gives you that will be diameter.
Yes, exactly.
13.75.
Repeat again.
13 point 13.8 when you round it up in his feet.
Okay, so let us. Okay, if you guys put 13.75, that is correct. If you guys put 13.8, that is also correct. But what is important is that in brackets, you're going to tell me this is to two decimal places and this is to one decimal place. This is important whenever you are doing calculations, right? You tell me how far you're rounding off your number. Once you state it, then your answer will be correct. If you round it off correct, right? If you round off wrong, then that's something else. Everybody understands how we got the response for this question?
Yes, miss.
Okay, so in the worksheet, I don't think there's another question that has to do with diameter, but we're going to be talking about the other part that has to do with calculation of um, circles. So let me share. So what we're actually doing today, I just wanted to review what we did yesterday with the pi and the diameter, calculating what pi is and calculating what diameter is. Sector of a circle. And a sector of a circle is like a slice of the circle. But this slice has very important details to it. The sector has to start at the center of the circle and needs to be made out of two radiuses. So if we take a look at this image, take a look at the green part that is cut out um, by two radius. What we call the smaller piece is the minor sector, and what we call the bigger piece is a major sector. So we can't just say, okay, the big part of the circle or the small part of the circle or the slice that I cut out. We refer to it as the minor sector and the major sector. A sector always, and I'm stressing on this, always originates at the center of the circle. So if I were to just cut out a slice at random from the circle, it might not be a sector, even though it has that same shape. So we have to be very careful and we have to look at what the question is giving us. A sector can be defined as the portion of a circle that is enclosed by two radii. And as I mentioned, the center of the circle, that's where it begins, and it is enclosed by two radii and the arc that forms them. And how do I go about finding area of a sector? Because it's a slice of a circle, I can't really do much about it. I can do one out of two things. The question can either, whenever you have a question that deals about sectors, they can either tell you find the area of the sector, or they can tell you find the perimeter of the sector. And the perimeter of the sector is a little bit more tricky, but what we're doing today is only the area of a sector. So look at the formulas that are there. If we take into account the area of a circle, we know that the formula is pi r squared, area of the entire circle. But in this case, I just want the area of one piece of the circle. So what makes it important is, like, for example, if I tell you guys find half of a circle, the circle has, let's say that the entire circle values 60, and I tell you find half of 60. I'm just finding that portion of half. What does half of 60 represent? And I go ahead and I do, well, half times 60 gives me 30, and I find my answer. And that is basically what we're doing here. Only because when we're dealing with circles, we're dealing with degrees, because degrees is the most accurate way of determining a portion of a circle. So let's take a look at that formula that is given to us there. If we take a look at these formulas, the one that we want to concentrate on is the one that deals with degrees. There is another formula that means the exact same thing, but we're not going to be working with that one because that one includes radians. And we're not going to be working with radians until you guys are in fourth form. Then we include the idea of radians. But for now, you are working with degrees. So who can tell me what does this symbol, what do we call that symbol?
Radius.
What do we call?
Diameter.
No, 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 no. This one right here.
Radius.
Go.
Circumference.
No, 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 no. This symbol right here. Remember, go back and
Theta.
very good. When we did trigonometry, remember when we did trigonometry and you had adjacent, opposite, hypotenuse, and you had this theta that represented the degrees? So theta is popping up again, showing up again. And we're using theta in our formula to represent how much degrees that sector is made out of. What is the magnitude of that sector? So over here, I have the first question, and that should be the first question that you guys should have as well. And we're going to be using the formula to do this, right? So the formula has that area of a sector is equal to theta over 360 degrees times pi r squared. Yes? So now, the first thing that I want you guys to do on your calculator is to make sure that your calculator is in degrees. It should have DEG at the top or a D on it. If it has another letter, if it has radians or if it has gradients, you need to change it, or else your answer will be popping up as something else. So make sure that your calculator is set to degrees. All right? Once you have that, now we can go ahead and use the formula. The question gives us basically what we need. So my first question, look at that one. And what is theta according to this question? What is theta?
210 degrees.
210. Very good. Over 360. Pi, we know that pi is 3.142. What is the radius?
12 inches.
12, and the radius is squared. So 12 squared. Right? And you guys can go ahead, and if you want to, make it look a little bit more simpler, we can do 210 times 3.142 times, what is 12 times 12?
144.
144, very good. All divided by 360. Go ahead and do this in your calculator and you give me a response. Do the multiplication. 210 times 3.142 times 144 equal sign. Then you divide by 360.
263.9.
263.9
Yes, miss.
units.
Inches.
Sure. Is it just inches? What are we looking for? What is the question?
Inches square, miss.
Inches square. Very good. Inches square. And because you did it to one decimal place, you need to write one decimal place. Yes? Okay, very good, David. I see your answer in the chat. Now, what do I expect you guys to submit to me is this. I had asked you guys to draw the circle, draw that representation. You don't have to measure using your protractor. Once it looks similar to the drawing, it's a scale drawing. You need to show me the drawing and you need to show me these. And you circle your answer or underline your answer because sometimes you guys send me so many pictures and your work is all mixed up that it takes me some time to figure out which one is which. All right. So, anybody has any questions with this one? Can I move on?
Move on, move on.
Anybody else? Because I only heard Jerome speaking. Did you
No question.
understand? Okay.
Yeah, no question.
Okay. So basically, for all of the 6 questions, because there are 6 questions, right? There are 6 questions, and all the 6 questions you have to do the same thing. So you need to be able to remember the formula, right? So I'm gonna write the formula: theta pi r squared over 360. All right, you can write it like that, or you can write it separate. It means the same thing. So, what is theta for this question?
90 degree.
90 degrees, very good. The value of pi. What is the value of pi? 3.142, very good. 3.142. And the radius?
6 yards.
6 yards, so it will be 6 squared, all over 360 degrees. Calculate that and provide an answer. What would be the answer? 90
28.3.
times 3.142 times 36 divided by 360. What did you say?
28.3
28.3. Very good. 28.3 units.
yards square.
Yards square. And then 1 dp. 1 decimal place, because that's how you wrote your answer, right?
Yes, miss.
Do I need to repeat? Is it clear?
Clear like what?
Clear.
Miss,
Yes.
this can you kindly show the working for number one again, Miss?
The working for number 1. There you go.
Okay, Miss, thanks.
Okay.
Like that way, put all of them, right?
Yes, all of those 6 questions that are in the second section, that is how you're going to be doing. Once you have the formula, you know what theta is and you know what the radius is, you should have no problem solving it.
Try for all of the question, all of all that I see formula for all of them.
Yeah. So
Okay,
let me open the activity. This is activity number 2, right? Yeah. So then if you take a look at activity number 2, it's called calculations with circles. It's worth 60 points. 60 points. I'm stressing on the 60 points, guys, because this is the biggest assignment that I have given. 60 points, and this is a section that we are working with. We have done number 1 and number 2. So you guys, the following number 3, 4, 5, 6, all of them are to be done using the same formula. You find the theta, you find the radius, you substitute into the formula, and you solve, and it's going to give you your answer. Right? So for these 6, this is the formula that you're going to be using. And we're going to be doing number 3, and then I'm going to leave the other 3 for you to do. This is the one that I did a while ago when we were reviewing diameter and radius. Right? This is the one, number 1. We already did that one. And the other questions we're going to be doing tomorrow and Thursday. Right? Um, but let us do the last one that I have here. This one, number 3. And then that will be it for today's class. Right? So using the formula again, area is equal to theta pi r squared over 360 degrees. Right? Area is equal to theta. What is theta for this question?
240 degrees.
240 degrees. Very good. The value of pi is 3.142. And what is the radius?
19.
19, and then 19 is squared over 360 degrees. What is your answer? Okay, I see one answer in the chat. Anybody else got that same answer?
756.2.
Okay, did you guys round off?
One decimal place.
Okay, so in this case, it is feet squared because you have feet over there, and then 1 dp. Any questions, guys?
No, miss.
Sure, sure, sure. Is it clear, clear, clear? Or are you guys lost, lost, lost? Okay, so I will leave the other 3 questions for you guys to do. And then now tomorrow, I need you guys to have the other questions, the word problems in your notebook. We're not going to be doing all of the word problems because I'm choosing on because only I think only one question talks about sector. And then tomorrow we're going to be doing area of a segment. So then we're going to be building on that. And then Tuesday we're going to be doing Tuesday. Now Thursday we're going to be doing length of an arc. So by Thursday we should be able to cover all of the formulas that are needed for this week. So anybody has any questions? No questions, guys?
No, miss.
No, miss.
So everything is clear, right, with this one?
Yes, miss.
I think this one was very, very easy, very straightforward to do. Tomorrow, area of a segment, little bit more difficult. You have to have a calculator tomorrow, guys, a scientific calculator, because you're going to be using a formula that has square root. So you have to have the formula for tomorrow. But you guys are free to leave. Enjoy the rest of your day, and I will be seeing you guys tomorrow for class.
Bye, miss.
Bye.
Bye, miss.
Miss,
Bye. Yes.
so this 3 LF that just said that we could do the same formula and everything, right?
Yes.
We just have to find the theta and the.
Yes, exactly.
Okay, yes. Bye.
Bye.